This lesson is called Solve One-Step Inequalities and Equations. Please make sure to write the date. And you can stop the video to copy down the notes and then start when you're ready. First are the definitions. Inequality. What is an inequality? It's a math statement that says two expressions are not equal. So when you see an inequality, you'll know because you'll have a symbol that shows they're not equal, like a greater than. If one side is greater than the other, they're not equal. You can have a less than. It's another one. We've also seen something called less than or equal, greater than or equal, this one. It does have a part that tells us it could be equal, but because it has the greater than, we still consider it an inequality. We're talking about it as if the two sides, the two expressions are not equal. And then the last one, of course, is less than or equal. So these are symbols that represent inequalities. They show that two expressions are not equal to each other. And then an equation is different because it is a math statement that says two expressions are equal. So for an equation, the only symbol you'll see for the relationship between the two expressions is the equal sign. That shows that they're the same value. The expressions have the same value. They are equal. Our first example will be x plus 6 equals -4. X plus 6 equals -4. So we're going to start off with an equation. We can tell it's an equation because there's an equal sign. That means this side, this expression has to be equal, has to be the same value as -4. So we're going to solve. Remember, solving means finding out the variable, finding out the value of that variable. What is x? That's what we're going to figure out. All right, something I have not shown you yet, and I like to have my students do this when they're solving equations and inequalities. I like to have my students draw something that I call the train tracks. So right there where the equal sign is, we're going to draw two vertical lines that might look like train tracks. And the reason we do that, well, there are a couple reasons. First, what it does is it helps us to remember that we're dealing with two expressions. There's an expression on the left, an expression on the right. And this sort of represents the middle where the equal sign is. So the lines that we draw help us to see that that's in the middle between the two expressions. So we've got our train tracks. And now we can follow our rules for simplifying. We know that we can get rid of zero pairs. That's one way to simplify. We can take away some things that are in common for the two expressions. And the third thing that we learned how to do is to add something to both sides to make zero pairs. In this case, let's start with that. Let's start with the adding something to both sides. Remember, we need to focus on the side where the variable is because that's our goal. Our goal is to figure out what that variable represents. So we don't really want to focus so much on the other side. Our focus, the first place we should look is to where the variable is. So we've got this x plus 6, and we know that we want to get the x all by itself so that we will have, in the end, we'll have something like this. We'll have x equals something. But right now we don't have the x by itself. We have x plus 6. What could we add here so that we could make zero pairs with a positive 6? Yeah, you probably said it. We could add a -6. If you add -6, that means you're going to have a positive 6 and a -6, which makes 0. So that causes it to go away. And that's beautiful because now the x is all alone and it just comes down here by itself. On this side, though, if we have to do the same thing we did on this side. So we've added a -6 on the left expression, we need to add negative 6 on the right. So now we've got a negative 4 plus a negative 6. So if we add negatives together, we just have a lot of negatives, right? We've got 4 negatives and 6 more negatives makes 10 negatives. So this is going to be a negative 10 down here when we add it up. So now we've discovered that x in our original equation has to be equal to negative 10. Let's check this to see if it's true. What we do is we say, okay, x is equal to negative 10. That means this x has to be negative 10. And we could put it in there. We could sort of imagine or just write it in there, negative 10. And kind of say, okay, if this is negative 10, then let's add it up. Negative 10 plus positive 6 would be negative 4. And that equals negative 4. Yeah, that's right. So what we did is we checked it by putting the number back into the original equation to see if it works. And it did. All right, let's do another example. Number 2, this time we're going to do an inequality, but it works the same way. We've got we've got 3 is less than y minus 5. All right, we want to solve this inequality. And just like we drew train tracks up here for number 1, we're going to draw train tracks for this inequality. And where we do that is right here at the inequality symbol, the greater than symbol. Did I say less than earlier? I don't know. This is a greater than, right? 3 is greater than y minus 5. And this is the middle of the inequality because we've got an expression on the left and an expression on the right. All right, so what are we going to do to simplify? How about if we add something to this side? We've got to focus on where the variable is. What can we add to the minus 5? Remember that we could change this minus 5 to, we could call it addition, right? We could change it to addition with one line, and then a second line makes it into a negative there. So we have plus a negative 5. What would go with a negative 5 to make 0 pairs? A positive 5, right? So add positive 5. Negative 5 plus positive 5 makes 0. And don't forget, if we add positive 5 on one side, we have to add positive 5 on the other side also to keep it fair. All right. So the 5s are gone and the y comes down all alone on the right side. And on the left side, it's 3 plus 5, which is easy. That's 8. And we keep our greater than symbol in the middle. Now remember, we can read it from left to right, but I always like to start with the variable because it makes it easier to understand. So we could read it backwards and say y, and the little point is pointing to the y, so it means y is less than 8. So y can be any number less than 8. So we could put, let's say a number less than 8. Well, 7's less than 8, so let's put 7. So if we check it out with 7, we say, okay, let's say what if y is 7? 7 plus negative 5 would be positive 2. Is that less than positive 3? Yeah, it is. 2 is less than 3, so that works. Good, we checked it out and it works. All right, let's practice our graphing too because we've done some of that. How could we graph this answer? The answer is y is less than 8. Let's just do a little graphing of an inequality here. We don't need very many numbers. So if we put 8 in the middle, we'd have 9, 10, 11 to the right, and getting lower to the left would be 7 and 6. So 6, 7, 8, 9, 10, 11. And now we're going to graph it. We need to put a circle on 8, but do we need an open circle or a closed shaded circle? Let's see. Well, y is less than 8. Okay, so if y is less than, that means it can't be equal. So we're not going to shade the circle. Y can't be equal to 8. So we leave it open, but y can be less than 8, and all the less numbers are to the left. All those numbers lower than 8 are this way. So we shade it to the left to show that y can be any of these numbers that are lower than 8. And by the way, could we graph this one, the equation? Sorry, lost my word there. I wanted to say equality, but that works, right? There's an equality here because it's an equation. So how do we graph x equals negative 10? Well, that's a real simple one. Draw a simple graph here. We could have negative 11, negative 10, negative 9, negative 8. Remember that on a number line, the smaller numbers go to the left. But when we're talking about negatives, they are smaller, but they look bigger because 11 looks like it's bigger than 10, but actually when it's negative 11 is smaller than negative 10. So the bigger numbers go to the right, moving towards 0. All right, so if x equals negative 10, that means x is not greater, it's not less than negative 10, it's just equal to negative 10. So what we do is we go to negative 10 and we put a shaded circle and say, here's x. X can only be negative 10. So that's how we would graph that. We don't need to shade to the right or shade to the left because x is only equal to negative 10. All right, so just to summarize, what we did was we solved one-step inequalities and equations. When we have an equation or inequality, the first thing I want you to do is draw train tracks and then think about figuring out what the variable is. Focus on the side where the variable is. Simplify to get the variable by itself. And make sure if you add something to one side, you have to add it also to the other side. And then you can solve, you can find out the value of that variable.